So this is a two-part problem. For the first part, we want to find a third-degree Taylor polynomial, which is Maclaurin, for f of x equals e to the x. And the beautiful part about e to the x is the function and its derivatives are all the same. So f prime of x equals e to the x, f double prime of x equals e to the x, and we're going up to the third degree. Now it's Maclaurin, so I will evaluate the function and all of its derivatives at 0. So I know f of 0 equals e to the 0, which is 1. So this is a very quick polynomial to write. I know that I'm going to have a 1 times x minus 0, because it's Maclaurin, to the 0 over 1 factorial, plus 1 times x minus 0 to the first over, I'm sorry, this first one is 0 factorial, this next one is 1 factorial, plus 1 times x minus 0 squared over 2 factorial, plus 1 times x minus 0 cubed over 3 factorial. So my third degree Maclaurin polynomial will equal, this simplifies down to 1, plus x squared over 2 factorial, which is 2. Just write it as 2 factorial, plus x cubed over 3 factorial. So we have the third degree. This is the same thing as x squared over 2 and x cubed over 6. So we have this polynomial, and the benefit of doing this and sometimes using these polynomials is, what if you needed to do a limit? If I try to evaluate this limit right now, I would try plugging in a 0, evaluate 0, e to the 0 is 1, 1 minus 1 is 0, divided by 2 times 0. So I have 0 over 0, and I know that if I use L'Hopital's, I can get an answer, and I'm going to do that to show you that we'll end up with the same answer, and usually close to the same answer. So this is the same limit as x approaches 0, the derivative of the numerator is e to the x, the derivative of the denominator is 2. I evaluated 0, so e to the 0 is 1, divided by 2 is equal to 1/2. This is one option. Another option is to use my polynomial. So we're going to use the answer, and my polynomial was for e to the x. So I'm going to take this polynomial and substitute it for e to the x. So this will be the limit as x approaches 0. My e to the x was 1 plus x squared over 2 plus x cubed over 6. That's for my e to the x. Now I'm going to subtract 1 and then divide by 2. X. So what you want to do is actually take this limit now, and if you do, you still get 0 over 0. But I can simplify a little bit here. The 1's cancel out, and then I have all of these x's going on, and one thing you can always do is just factor out an x from this. I could change the denominators, and a quick way to actually fix the denominators if you want is to multiply by a very clever form of 1, and I can choose 6 over 6. If you want to, you don't have to, but that would make this the limit as x approaches 0 of 6x, and I'm distributing the 6, so this will be a 3x squared plus x cubed over 12x. And here you can actually see the common factor, but this is another option here. So every term has at least one x in it. So this would be the limit as x approaches 0, and I'm going to cancel out 1x. So this is 6 plus 3x plus x squared over 12. And if I evaluate now, I get 6/12, because this goes to 0, this term goes to 0, and this term goes to 0. So I'm getting 1/2, whether I use L'Hopital's or use the Taylor polynomial approximation for that limit.